Hey everybody, this is Mr. Walsh, and today we're going to be learning about bonding types. And so there are 4 types of bonding that we're going to go over. And this is the first part of Unit 3, which deals with molecules. The 4 types of bonds are ionic, covalent, metallic, and network solids. There's other types of bonds and other types of molecules, but these are the 4 that we're going to focus on. And actually, believe it or not, these are the only 2. This is the only time you're ever going to see these 2. I'll give you some keywords to look for here, but ionic and covalent are the ones that are we're really going to focus on. In fact, we're going to move forward after we talk about bonding and the things that go into bonding. We're going to spend a whole section talking about ionic bonding, and then we're going to spend a whole 3 sections or half the unit talking about covalent bonding. So there's a lot there going on. But you can write down all of these words and definitions, but the key that you want to write down is that an ionic bond has to do with the transfer of electrons, and a covalent bond has to do with the sharing electrons. The other thing that we have is that an ionic bond is between metals and nonmetals. So if you have a periodic table, okay, so an ionic bond is between metals and nonmetals, or the left side and the right side of the periodic table. A covalent bond is between 2 nonmetals, so 2 nonmetals. And then a metallic bond, believe it or not, is between 2 metals. And then you have something called a network solid, which is just a whole bunch of covalently bound atoms together. This would be something like diamond, okay, because they're this that makes them extremely strong. It's crazy. So we'll talk more about these. Metallic bonds, I just want you to know that it's a sea of electrons. Okay, you're going to see that phrase. You're going to see that phrase a lot. That's really the only thing that's going to stick out about these other things. So if you have 2 metals, or you see the sea of electrons, we know that it's a metallic. So if we're talking about ionic bonds in details, again, we talked about this, but this is how an ionic bond forms. Okay, and so I'm going to very generally describe each of these steps, and you can see them there, or they're published in the notes. If it's hard to see. But what happens is you have a metal. Let's just take a very straightforward metal like sodium, okay? And what that has 1 valence electron. That valence electron leaves, and that means that this becomes a 1 plus charge. It loses 1 electron, it becomes a 1 plus charge. So that's what that happens. And then a nonmetal like chlorine will gain the electron. So this electron just doesn't go off into space and do nothing. It actually will come over here to chlorine. I'll make it like an X so that you know that it's the one that was gained. Okay, and so because it gained an electron, that becomes 1 minus. So that becomes a negatively charged ion. Okay, and remember, positively charged, this is a cation ion. This is an anion. Okay, and so now that they are oppositely charged, right, we have a 1 plus. Let me clean this up. I'll bring this down here. We have a 1 plus and a 1 minus charge. These 2 things, because they're opposites, are attracted to each other. Okay, the 1 plus and 1 minus, opposites attract, and so there's an attraction that brings these 2 together. That is called the ionic bond. And the driving force is that we end up with an octet of electrons. So this gives up 1 electron to form an octet. This takes the 1 electron to form an octet, and we'll talk about this a little bit later, okay, in the next video. Okay, so because we have an attractive force, this is not a physical linkage between the atoms. Okay, this is not a physical linkage between those atoms, or ions actually. Okay, and that gives these properties, high boiling point, brittle, conducts electricity, to ionic compounds. Okay, and so ionic compounds are all of these things because this is an attractive force. It's hard to see this. The small ones are Na and the big ones are Cl. So what happens is, again, notice that these ions, this is a positively charged ion, is attracting a negatively charged ion, and they're not bonding. They're not bonded together. They're attracted. They are not connected. They're not physically linked. And so, but this positive has more space to attract negative, so there's an attraction between a negative here. And then this negative and this negative attract another positive, and that's what this is. Okay, and then this positive charge attracts this negative, this negative, this negative, and this negative. So what you get is you get this giant organized arrangement of positive and negative ions. Okay, so you can imagine that this is in 3 dimensions. If you make it go back, you have a small sodium ion here, and then a larger chloride ion here. And so, I mean, this is 3-dimensional, and this is one of the reasons why ionic compounds are solid, is because the ions allow themselves to arrange in this sort of regular pattern. Okay? And so ionic solids or ionic compounds are typically solids because of the way that it is bonded, or that attractive force that holds them together. And then the other one is a covalent bond. This one is a little easier to understand. It's between 2 nonmetals. Okay, so again, when we have our periodic table, we're talking about these few elements over here. Okay, and the idea here is that valence electrons are shared. So I'm going to show you what that looks like. So I'm going to take carbon and I'm going to take chlorine. And carbon has more than 1 valence electron. It actually has 4, so I'll make 4 dots around this. And chlorine has 7, so I'm going to put 7 dots around this. But the point is that these electrons will be shared. And so now chlorine and carbon are sharing these electrons. And so this creates a physical linkage, an overlap in the valence between these 2 atoms. Okay, it doesn't form ions. The atoms stay atoms. Okay, and so that is a covalent bond. And because the bond is a physical linkage, it creates low melting points. They don't conduct, and they're actually brittle, or can be brittle when those compounds are formed. So what we have here is actually 3 separate molecules. Each one of these is a natural gas molecule, or methane. Okay, and so you can see the electrons that are overlapping here in each of the carbons and the hydrogens. And the reason why I show you this is because each unit, each methane, notice, is separate. Okay, there's no force holding these molecules together. Okay, they're just kind of their separate thing going about their business. More on this a little bit later, but I just wanted you to know that because these things are separate and not attracted to each other much, it gives rise to this being a low melting point. And so methane, or natural gas, is a gas at room temperature, as opposed to sodium chloride, which we talked about in the ionic compounds. Sodium chloride is a solid at room temperature. And so it has to do with their bonding. And so compounds that are covalent have the ability to be more loosely arranged and kind of move independently from each other. Okay, so that is the types of compounds, the types of bonding that we will see in compounds. Metallic and network solids, we only saw at the very beginning. We're not going to go into detail about those. Okay, so everybody, have a great day.